Imagine this. You're watching a high-altitude NASA research plane, a real veteran of science missions, coming in for a landing. But something is seriously wrong. The landing gear, it just won't come down. Now, this isn't some scene from a movie. This was the very real and very tense situation that played out in the skies over Houston.
That's exactly how local television described the scene at Ellington Field. I mean, can you picture it? The pilot, facing a total mechanical failure, has to bring this massive aircraft down on its belly, literally sliding down the runway in a shower of sparks. It's a scenario every pilot trains for, but hopes they never, ever have to face.
And look, before we go any further, let's get to the most important part of this whole story. Thanks to some absolutely heroic flying, the crew was not harmed. NASA spokesperson Bethany Stevens confirmed it. Everyone walked away completely safe.
So what the pilot pulled off is what's called a gear-up landing. It is an incredibly difficult maneuver. You're essentially using the belly of the plane itself as the landing gear, carefully managing all that speed and energy as it scrapes to a halt.
Okay, so let's rewind a bit and break down exactly what went down on that Tuesday morning over Houston.
The basic facts are pretty straightforward. One of NASA's 3 high-flying WB-57 aircraft ran into a mechanical problem right over its home base at Ellington Field. The landing gear failed to deploy, which forced that unbelievable belly landing. And you know, the outcome wasn't luck. It was pure skill, a real testament to the crew's training.
But here's the thing. To really understand why this specific plane is so important, you have to know that it's not just any plane. The WB-57 has a truly incredible history that goes back decades, long before it ever flew for NASA.
This plane's family tree goes all the way back to 1944, starting out as a British bomber. After it set a record-setting transatlantic flight in '51, the U.S. Air Force just had to have it. It served in Vietnam and even flew these secret missions, sniffing the air for signs of nuclear tests. It wasn't until 1972 that NASA looked at it and saw a completely different potential, and gave it a new life as a scientist. I mean, just think about that transformation for a second. The very same kind of plane that was once a tool of war, flying bombing missions and hunting for nuclear debris, is now one of NASA's most prized scientific instruments, hunting for cosmic dust from comets. It's a true swords to plowshares story, but for an airplane.
So what exactly does this Cold War veteran do for NASA today that makes it so absolutely essential? Well, it's all about altitude. The WB-57 operates at over 62,000 feet. That is the edge of space, a region way, way above where commercial planes fly that's incredibly hard to study.
And from that amazing vantage point, the science they do is just incredible. It flies over massive hurricanes, it collects dust from comets, and it even analyzes the plumes from rocket launches like the Space Shuttle and Starship. Oh, and keep this in mind, it was scheduled to be a key observer for the Artemis II mission to the moon.
And that right there brings us to why this one emergency landing is such a massive deal for the entire scientific community.
Because NASA only operates 3 of them. That's it, just 3. This isn't just a fleet of planes, this is the entirety of the agency's high-altitude research aircraft fleet. And as of that Tuesday morning, one of them, the one involved in the landing, is now grounded indefinitely.
The impact is huge. In a single moment, NASA lost a full third of its capability for this unique kind of research. For a fleet this small and this specialized, losing even one aircraft, even temporarily, creates this huge ripple effect. It's a logistical nightmare for all the scientists and mission planners who are competing for flight time on these irreplaceable planes.
So, with the plane safely on the ground and the crew safe, the focus now shifts to what comes next. As you'd expect, NASA is launching a full-blown investigation. Their job now is to figure out exactly what caused that mechanical failure and, more importantly, how to stop it from ever happening again. But this leaves us with some very big unanswered questions. Can the plane even be repaired after a belly landing like that? What is the investigation going to find? And remember that Artemis II mission we talked about? Well, we now have to ask what this means for NASA's plans to watch it from the sky. The pilot's incredible actions saved the crew and probably the aircraft itself. But the whole incident leaves a critical question hanging in the air. For a program that relies on just 3 unique, vintage planes, what does the future of science at the edge of space actually look like when one of them is suddenly taken out of the picture?